We're looking for 3-digit numbers, so there are 3 events here. We're going to multiply. If repetition is allowed, there are 5 different numbers I can choose from there, and I can do that 3 times. And so I think that's 125. And if repetition is not allowed, it would be 5 times 4 times 3, 20 times 3 is 60. So I think it'd be 60. Coin is tossed, a die is rolled, a card is drawn from a deck. How many different possible outcomes? There are 3 events. Coin has 2 outcomes, die has 6 outcomes, and a deck of cards has 52 outcomes, not including the joker. Just use your calculator and multiply that to get 624. Family of 4 children, how many different boy-girl birth order combinations are possible? And those 2 things are different, right? So birth order, there's a whole thing about birth order that it makes a difference if you're oldest, youngest child, that kind of thing. So in this case, it makes a difference. So this would be, there are 4 children. There are 2 options each time. So whatever 2 to the 4th is, there are 16 different ways that we could order those letters, and for different boy-girl combinations. So in this one, you have to decide, is order important? If you get a cookies and cream and then vanilla, it doesn't matter which scoop is scooped first. And it doesn't really matter for a banana split which one is first. And so we're going to say NCR is going to be our method here. So I think this would be just 15, choose 4. Just to type that calculator in case you don't know. I think you probably do, but menu probability. That's a combination. And then you choose 15, comma is in the bottom left, comma 4. And you get the 1365. 3 letters of security code. What is the max number of codes you can generate? And they're letters this time, not digits, right? So this is going to be 26 times 26 times 26. It doesn't say anything about repeats. Get your calculator out and multiply those to get that answer. How many students are in this class? Oh, this is kind of a tough problem. So this is not easy, but if you think about it, so it's just how many students can stand in a row. So this is a classic. There's nothing difficult about how it's set up. For example, if there were 3 students in the class, it would be 3 factorial, which would be 3 times 2 times 1. There are 6 different ways that 3 students could stand in order. So if you get that idea, this question is really this. N factorial is going to equal 120. It's definitely bigger than 3 because there's only 6 there. You could almost do 4 in your head. 4 factorial would be 4 times that is 24. 5 factorial would be 5 times that. That's 120, I think. But you could just, again, kind of type it in your calculator and be like, okay, let's just try a few. We don't really know a way algebraically to solve for that. But if you can get to this step, you could probably just test a few numbers and figure out that the answer is 5. So it's 5 students are in this class. Well, it's a pretty small class. And this doesn't mean it's going to be used on every problem. This could be used in one of these problems. Maybe just a basic one like that could also be used. So let's just look at some of these. So 35 students tried out for the volleyball team, made cuts, chose 15. So it doesn't really matter what order you were selected in, like you're first person list or last, you still make the team. So I don't think order is important. So I'm leaning towards NCR here. And so this would be 35. Choose 15 of those, and then you just type that in your calculator to get 3. Wow, there's a lot. When you type that in your calculator, you get a huge number, 3 billion different combinations of choosing 15 people out of 35. So you want to look for things like repeats. I see that there's an M repeated, there's an A repeated, there's a T repeated, And is that it? So no H-E-I-C-S. Okay. So we got 3 letters repeated. So this is a case of a distinguishable permutation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 11 letters. So in the numerator would be n factorial. There are 2 M's. There are 2 A's. There are 2 T's. And the rest are 1s. If you want to write the rest, you can 1 times 1 factorial times 1 factorial, but that's really it. And so you just literally just type that in your calculator and you get 4,989,600. You arrange a row. This is another distinguishable permutation. So you count up, there's 5 and 2 and 7. So that's a total of 14 balls. So in the numerator is n factorial, but there are 5 red, so 5 factorial, 2 white, so 2 factorial, and 7 of the blue, so 7 factorial. Type that in your calculator is 72,072. So this one's kind of a tough one for students if you've never seen Morse code. Let me just show you something for a second. So if you look over here, just like A is dot dash, B is dash dot dot dot, C is dash dot dash dot. Some of these are 1 character letters, like E is a 1 character letter, it's just a dot. A is a 2 character letter, it has a dot dash. I is a 2 character letter, it has a dot dot. M is a dash dash, it's a 2 character letter. Some of these are 3 character letters, like O is a dash dash dash. Some are 4 character letters. I think that's the max there. There's no more than 4 character letters. But that's the idea of this, that you can do the whole alphabet with dots and dashes in groups. So you go dot dot, dot dot means I, dot dash, that means A, etc. So you've got this whole letter. So a sequence of dots and dashes with repetitions. How many letters can be used in Morse code if 3 or fewer symbols are used? So let's go with 1 symbol. So how many different letters? I don't care what the letters are. I don't need to look at that chart. There are 2 options. There's a dot or there's a dash. So there are 2 options for that so far, right? 2 character letters or 2 symbol letters. Like I think the A was a 2 symbol letter. So dot dash, dot dot, dash dot, dash dash. There are 4 possible combinations there. 3 symbol ones. So that could be dot dot dot, dot dot dash, dot dash dot, dot dash dash. I think I've got all the ones that start with dot there. So now let's go dash, 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 dot, dash, dot, dash, dash, dot, dot. I think I've got all those. So I think I have a total of 8. We actually could have gotten this easier. I just wrote them all out for you. So it looks like there's a total of 6 plus 8 is 14 is my answer there, I believe. You could have just done 1 symbol letters. There's 1, so there's just 2. 2, you do 2 times 2 is 4. And if you have 3 positions, there's 2 options for each one. 2 times 2 times 2 is 8. You didn't have to write it out like this, but that's the idea. To do a full alphabet, you need 4 characters, right? We just saw that with the actual code, but 14 characters could be covered by 3 symbols. YOLO Yogurt Shop has 25 different toppings. If you want to get 5 different toppings, how many ways can you do this? So does order matter? No, it doesn't matter if you put hot fudge and then chocolate chips or whatever. So NCR is our method. So it'll be 25, choose 5. And when you type that in your calculator, I think it ends up being 53,130. Anagram, we talked about that. Yeah, so like here are different like anagrams. They don't have to actually spell words, it's just like using the letters. Oh, anagram. Okay, anagram is where you take the letters and just mix them up, right? Is that what it is? Okay. So how many, but it doesn't have, like, I don't think Tenelger is a word, so, but it has all those same letters. So Triangle. Are there any repeats there? So I don't think there are any repeats. So this is a pretty straightforward problem, right? So there are Triangle. So it looks like there's like 8 different decisions. So once I have 8 different decisions for the first letter, and then 7, and then 6, and then 5. Once I choose each letter, the number of choices goes down. So the answer would just be 8 factorial, which I think is 40,320. So those formulas may be used here if you need them. Remember, it consists of tossing a coin, rolling a die. Okay, list every element in the sample space. So you toss a coin, so I might get like a heads. Then I roll a die, I might get a 1. So heads 2, heads 3, heads 4, heads 5, heads 6. Those are all the options with heads. Now let's go with tails. Tails 1, tails 2, tails 3, tails 4, tails 5, tails 6. So it looks like there's 12 different options. But the sample space is the list of all of them. So you actually have to list them out. I just, it helps to kind of like see that there are 12 because we'll use that here. Find the probability of getting heads and an even number. So I want to get heads and even. There's like 1 there, there's 1 there, 1's there. So there'll be 3 out of 12, which would be 1/4. Of getting heads and a number greater than 4. So that would be these two. So 2 out of 12, which is 1 out of 6. That's red card or a 10. So we could use that formula. We could actually go, okay, probably getting red card is 26 out of 52. Plus the probability of getting a 10, there are 4 of those. So 4 out of 52, it's a 4 out of 52. Minus the overlap. Are there any cards that are both red and 10s? There are 2, the 10 of hearts and the 10 of diamonds. So that'd be 2 out of 52 because I double counted those 2 cards. So 26 plus 2 is 28. So 28 out of 52 would be the answer. Of course, you might be able to simplify that. I think that's 7/13. You could also draw. It might be easier to draw and say, okay, this is the red cards. This is the 10s. There are 2 cards that are both. There are 2 cards that are not red. They're black 10s. And there are 24 cards that are red but not 10s. If you add those up, 24 plus 2 is 28. And you get the same answer doing it that way. So I want to get all kings. There are only 4 cards drawn. Order doesn't really matter, so I'm going to use NCR here. And so in the denominator is going to be 52, choose 4. Those are all the possible ways I could do it. For the numerator, I only want kings. There's only 4 kings. I want all 4 of them. And so you just type this in your calculator. It ends up being 1 over, I think when you type in 52, choose 4, you get 270,725. All spades, okay, so this time I'm going to get all spades. So again, order is not important. So 52, choose 4, and 13 spades, I'm going to choose 4 of those. So you can type that in, you get 11 over 4165 when you type it in your calculator. All the same color. So this one's a tough one. You really got to think about this. So I'm going to change the question slightly. So let's pretend first it's just red. So I'm going to pretend the question was all red cards. And then I'll show you how we deal with the same color because it's a complicated question. This is really tough. Okay, so let's pretend the question was all red. Okay, so if it's all red, we want 52. Choose 4. And we want 26 red. We want to choose all 4 of those. So we get that answer, which is I believe 46 out of 833. That's the probability of red. If I did that again for black, if this makes sense, I'd get the same answer, 46 out of 833. I'd set it up the same and get the same answer. So I really would be happy, all the same color. I'm happy if it's all red. I'm happy if it's all black. So what do I do with those? I'm going to add those up to get a total of 92 out of 833. Pretty tough problem. Because again, they could have like made it easier, just said, oh, what's probably getting all red? What's probably getting all black? That would have been a much easier problem. But you had to kind of double your answer. Red and black were equally likely there. So it's 4 red, 3 white, and 1 yellow, so a total of 8 balls. A red ball is not drawn, so I don't want red, so there are 4 balls that are not red, so 4 out of 8, or 1/2. A red or white, so I'm happy with red or white, so a red there are 4, white there are 3, so that would be 7 out of 8. Okay, binomial theorem, it's good. So 80% chance of success, shoot 7 arrows, what is the probability of each event? So he never hits the target. So P is I don't want to hit the target, so that's 0.2. Q would actually be hitting the target, which is 0.8. N is shoots 7 arrows, so N is 7. And R is how many he wants. He wants to never hit the target, so he wants 0 successes. Okay, so now at this point, you just kind of plug it into your calculator at that point. So this is going to be, so this would be, let's see, NCR. So this would be 7, choose 0, times P, which is 0.2, to the R, which is 0, times 0.8 to the 7th. So you get your calculator out. You go NCR 7,0. Curious what that is. Oh, that's just 1. This is just 1, right? Anything's a 0. So we end up just having to do 0.8 to the 7th. 0.8 to the power of 7. So the answer should be 0.2097. He hits the target each time. So this time we want to hit the target. So this would be P equals 0.8, trying to hit the target. Q is 0.2, that's not hitting. N is 7, and he wants to do this every single time, so R is 7. So then you would type it in your calculator, you would say 7, choose 7, times 0.8 to the 7th, times 0.2 to the 0. NCR 7, 7, by the way, that's 1. 2 to the 0, that's the 0 power there, that's 1. So this ends up just being 0.8 to the 7th. So 0.8 to the power of 7. He never hits the target. Hits the target, so this would be 0.2097. It's the same question, kind of. Same probability of never hitting the target as hitting the target every single time. It's interesting. Okay, so hits the target more than once. So this is a great idea of the complement. So the probability of, let's say when R is greater than 1, is going to be equal to 1 minus the probability of R less than or equal to 1. So I've got 2 to plug in there. So this is going to be, we've got to plug in an R value of 1 and 0 there. So 1 minus, this is going to be NCR, so 7, choose 1, times you hitting the target, so 0.8 to the first, times 0.2 to the sixth, times NCR again, so 7, choose 0, times 0.8 to the 0.8 to the 0, times 0.2 to the 7th. You type that all in your calculator, so it's 1 minus all that multiplied together, basically. So the R value of 1 and the R value of 0 there. And you'll get an answer. I think it's, not sure what the answer is. I don't have it written down. Here's the target at least 5 times. So this is going to be P is 0.8, Q is 0.2, N is 7, and R is 5, 6, and 7. So I've got to do this thing 3 times and add all of these, right? So that's the idea of this. I've got to, plug that in 3 times to the formula. So it'd be NCR, which is 7, choose 5, times 0.8 to the 5th, times 0.2 to the 2nd, that's a 0.8, plus 7, choose 6, times 0.8 to the 6th, times 0.2 to the 1st, plus NCR, so it would be 7, choose 7, times 0.8 to the 7th, times 0.2 to the 0. And you type that in your calculator and you get an answer. Coin is flipped 5 times. What's your probability you get exactly 3 heads? So this is binomial, right? So we want exactly 3. So P is probability of success is 0.5. Q is 0.5. I want heads. That's why. So probability of heads is 0.5. N is flipped 5 times. And R is equal to 3. So just plug it into the formula. Recognize this is binomial. So it'd be 5, choose 3, times 0.5 to the 3rd, times 0.5 to the 2nd. And type that in your calculator. Probably getting at least 3 heads. So this would be N or P is 0.5, Q is 0.5, that's tails, probability. N is 5 again, and at least 3, so R equals 3, 4, and 5. We've got to do that thing 3 times, so that plus, I'm just doing that here, plus NCR, so 5, choose 4, 0.5 to the 4th, times 0.5 to the 3rd, plus, now we've got to plug in 5 as well, so 5, choose 5, 0.5 to the 5th, times 0.5 to the 0. And type that in your calculator and get it. Its first heads is on the 3rd flip. Okay, so first heads on the 3rd flip. So I want to get tails. I want to get tails and then I want to get heads. That's definitely what I want to happen. So the probability of getting tails is 1 out of 2 times 1 out of 2 times 1 out of 2. So we get 1 out of 8 would be the answer here. Angie wins $10, so she rolls a 6 and she loses $1 otherwise. So we're going to find the expected value. So there is a win column here and a lose column. And we're going to have amounts and probability. So the amount and the probability of that happening. So she could win 10, she could lose 1. The probability of winning 10, let's see, if she rolls a 6, so 1 out of 6, and this would be 5 out of 6. So then you're going to multiply amount times probability, 10 times 1/6, plus the amount times probability, so -1 times 5/6. So you get 10/6 minus 5/6, which is 5/6. But we don't like that answer. We want to put it in decimal form, so about 83 cents when you divide that out, 5 divided by 6. So you lose, you win, wow, you win 83 cents every time you play on average. It's pretty cool. Card is drawn from a deck. You win $104. Card is ace, $26 if it's a face card, and $13 if it's 8 of clubs. Oh, what's the probability? So there's no downside in this game. This is a great game, right? So there's no downside. There are 3 options, right? So you could get an ace. You could get a face card. And you could get an 8 of clubs, 8 of clubs. Right, those are the outcomes we want. So this is going to be amount, and this is probability. So you get $104. Face cards, you get 26. And 8 of clubs, you get 13. Probably this is 1 out of 52. Face card is 12 out of 52. And then 8 of clubs is 1 out of 52. Then you're just going to multiply it out there, so you'd have 104. Oh, I'm sorry, aces, there are 4 of those. Sorry, 4 aces. So 4 out of 52, sorry. Plus 26 times 12 over 52, plus 13 times 1 over 52. And you just type that in your calculator, and you get 57 over 4. Which is 14.25. On average, you're going to get about $14 every round, $14.25 a round. 8 white balls, 2 black balls, shoots 2 balls from the bag, wins $5 if he does not pick a black ball. Okay, so again, there's no downside to this game. So if he wins, really, this is weird. So if he wins, that's the only outcome here. Okay, so let's see. So the amount and probability of this, you're going to win $5, and the probability of not picking that. Let's see. So there's how many different options are there? Let's see. So this would be. So that contains 8 white balls and 2 black balls. Okay, so in the denominator would be you're choosing 2 balls. So it's going to be 10, choose 2 in the denominator. In the numerator, we want to pick one of the 8 white balls, or 2 of the 8 white balls, right? So it's going to be, it doesn't matter the order though. So 8, choose 2. I want to choose both of those. And then you just type that in your calculator. So it'd be 5 times that. Whatever that is in your calculator, and you end up getting 5 times 0.622, which is 3.11, so $3.11. One more. See, if it contains $1 million, it's locked. You pay $1 for one guess for a 6-digit combination. If you open the lock, you get to keep the $1 million. What is your expectation? So you either win or lose. So there's 2 columns. There's an amount and a probability. And so if you win, you pay $1, right? So that would be $999,999 you get back. If you lose $1. The probability of winning is 1 over, let's see, 10, 1, 2, 3, 4, 5, 6. So it'd be 10 times 10 times 10 times 10 times 10 times 10, that many different options. So 10 to the 6th power. And this would be, which by the way is 1 million. So this would be 999,999 other ways of getting, so over 10 to the 6th or over 1 million. And then you multiply this times this, plus this times this. And actually the expected value is 0 when you do that. And you add those 2 things. So I'm running out of time here, so I just shortcut that one. The answer is 0.